Hello everyone, this is the first lesson recording for IM2, December 10th, 2020. We started off with the quiz on polynomial definitions and multiplied polynomials. And then we did a quick warm-up, factoring out the GCF from last lesson. Pause the video and see if you can solve them yourself. And the answers are in 3, 2, 1. Looking at the first two terms, 4x squared y and 2xy, what are the common factors to both the terms? Well, 4 and 2. 2 is a factor. We have two x's and a y. We have one x and a y. So that means at least there is an x and y in each one of them. So there is 2 and xy in each one of them. So you factor out 2xy. So 2xy times what is 4x squared y? That's going to be 2x. And 2xy times what is 2xy? It's going to be plus 1. Okay? Do not lose this plus 1. This is very, very significant. You can always check your answers by multiplying this out using the distributive property. 2xy multiplied by 2x. Is that 4x squared y? Yes, check. 2xy multiplied by 1. Is that 2xy? Yes, check. Now, next problem is 3x squared plus 18x plus 24. Now, are there any factors that we can factor out? First, we look at the numbers 3, 18, and 24. Okay, well, I know that 18 is divisible by 3. Is 24 divisible by 3? Yes. So that means 3 is a factor. Now, do we have any variables that we can factor out? I have two x's here, one x here, but there are no x's here. That means variables, remember that it has to be common to all three terms. It's not enough that two of them has it. It has to be common to all three. That means 3 is the only common factor we can take out. So then you take out the 3 outside the parentheses. 3 times what is 3x squared? Just x squared. Now for the second term, 3 times what is 18x? It's going to be 6x. 3 times what is 24? That's going to be 8. Similarly, you do the third problem, and you would get 4 multiplied by x squared minus 4x plus 3. You can always check your answers by redistributing and making sure you get the original expression. D, looking at this, what are the common factors? 2, 10, and 72, they're all even. That means at the very least, 2 is a common factor. And 2 is the biggest number, so that actually solves it. What about the variable? Now, we have x squared y, so two x's and a y. I have one x and one y, but then I only have one y here. So the limiting factor is the y, isn't it? Okay, so that means y is common to all three, so I can take out 2 and y. That's 2y. So x squared is the first term because 2y times x squared is 2x squared y, and 2y times negative 5x is negative 10xy, and negative 36 times 2y is negative 72y. Great. I hope that refreshed your memory from last lesson. Now we are going to be talking about quadratic expression. Okay, polynomial is a quadratic if it can be written as ax squared plus bx plus c. So you're always going to see a actually it does not have to be a trinomial, but what determines if it's a quadratic is this exponent of 2. So if it's a polynomial, remember there is a definition for polynomial and non-polynomial. It has to be polynomial whose highest degree is 2. If the highest exponent is 2 on the variable, then it's a polynomial. It's a quadratic, I'm sorry. So quadratic example, x squared plus 2x plus 4, the highest exponent is 2, so this is a quadratic. 3x squared plus 1, the highest exponent is 2 again on the variable x, so this is a quadratic. And then last one, negative 10x plus 2x squared. Okay, this is not written in the standard form. That is the reason we always like to write polynomials in the standard form by putting the 2x squared first, followed by negative 10x. Then it's really clear. is the highest degree 2 or is it 1? So in this case, negative 10x plus 2x squared is a quadratic example. Because you have the exponent of highest degree is 2 here, and highest degree is 2 here, and highest degree is 2 here. Let's look at some not quadratic example. Okay, this one, 2x squared plus x cubed plus 4. This is not quadratic. Why? Because you have x to the power of 3. Okay, so the highest exponent is 3. Therefore, this is not quadratic. And this is, again, the reason we like to write polynomials in the standard form. That is the highest degree right at the front, and then the variables with the different exponents in descending order. So x cubed at the front and then x squared followed, and the constants are always going to be coming at the end because that's same as x to the power of 0. And 3x plus 1 likewise is not quadratic because the highest degree is not 2. The root origin of quadratic, the word quadratic, comes from the word quadrare, meaning to make square, okay, or rectangle to be more precise, but this is really, well, in a rudimentary term, a square. This is not coming from the word quad, which means four, like quadrilateral, which means four-sided. So, yeah, do not get that confused, please. All right, so I want you to tell me in private chat, is this a quadratic expression or not? Yes or no? Okay, I should be able to hear from everyone. Okay, so is this quadratic or not? Remember, it has to be a polynomial and it has to have the highest degree to be 2. So in this case, yes, highest degree is 2. Is next one polynomial, quadratic, 10x squared plus 1? Yes. What about 2x squared plus 3x cubed? No, because the highest degree is 3 here. What about negative x squared plus 5x? Yes, even though there's a negative in front of the x squared, it doesn't. We don't really care about the coefficient of x squared. We just care that it is x squared or y squared or something squared. It can be different variables, but it has to be squared. And finally, what about this? X plus 4 multiplied by x plus 1. Well, if we multiply this out using the area model or distributive property, then you do know that the highest degree will be x times x, so that's going to be x squared. So x squared plus something x plus some number. So yes, this is a quadratic. All right, so what are factors? We started talking about that last lesson. When two or more expressions are multiplied together, each of the expression is a factor of the product. So for example, factor of a number, we said that 3 and 4 multiplied to 12. So 3 and 4 are factors, and 6 and 2 are factors, and 3 and 2 and 2 are also factors. So 2, 3, 4, and 6 are all factors of 12. Now factors of polynomial. Okay, 3x squared plus 6x. Remember, we can factor out GCF. That's what we did. We took out what was the common to both was 3x. So we took that out and we said 3x multiplied by x plus 2 is exactly the same as 3x squared plus 6x. So this is the factored form. This is the expanded form. Okay, so this tells us that 3x squared plus 6x, the factors of 3x squared plus 6x are 3x and x plus 2. So the factors of 3x squared plus 6x are x plus 2, that's a factor, and x is a factor, and 3 is a factor, and 3x is a factor too. They're all factors of 3x squared plus 6x. All right. What about this? X squared plus 4x plus 3 is equal to x plus 1 times x plus 3. Let's quickly check. Does this work out? X times x plus x is going to be x squared, plus x times 3 is going to be 3x, plus 1x. 1 times x is 1x. So 3x plus 1x is 4x. And then finally, 1 times 3 is 3. So yes, this is a factored form of x squared plus 4x plus 3. That means x plus 1 and x plus 3 are all factors of x squared plus 4x plus 3. So how do we go about factoring quadratic expression? We learned how to factor the greatest common factor, the GCF. Okay, now focus on factoring quadratic expression with the a is equal to 1. That means the number in front of x squared is just 1, or there is no number, right? So it's always going to be in the form of x squared plus bx plus some c, where b and c are some numbers, positive or negative. It does not have to be a whole number, but for simplicity's sake, we're just going to keep it to whole number for now. All right, so pattern from multiplication. Let's multiply the following polynomials using full distribution. The numbers are very, very similar here. We're dealing with 4 and 2, 4 and 2, 4, 2, 4, 2. However, we're dealing with different signs. We're multiplying x plus 4, x plus 2, x minus 4, x minus 2, and then x minus 4, x plus 2, and x plus 4, and x minus 2. And let's see how this makes a difference. Okay, so I've talked to you about FOIL method. I've talked to you about distributive method. Okay, now that you guys all are hopefully understanding how to use distributive method, FOIL is just simplified version of distributive method when you're dealing with binomial multiplied by binomial. So I do not mind you guys using that. In fact, that actually makes it a little bit simpler. So I mentioned last lesson that FOIL stands for F is the first, O stands for outside, I stands for inside, L stands for last. What that means is when you're multiplying binomial with binomial, you first multiply first term of each binomial. First with first, x times x, that's going to be x squared. And then you multiply outside terms, that's the outside. X and plus 2 are the outside terms. You multiply those. And then you multiply the inside terms. That's the 4 and the x. And then lastly, the last with last. So that's 4 and 2. So when you do that, you get x squared from the first with first. And then first outside is x times 2 is 2x. The inside is 4 times x is 4x here. And then last is 4 times 2, which is 8. And you get 4x squared plus 2x plus 4x plus 6, which leaves you with x squared plus 6x plus 8 after you combine like term. If you do the same thing with the next term, next binomial multiplication, you are you so first with first is x squared. Outside, the x with negative 2 is negative 2x. Inside is negative 4 times x is negative 4x. And then last is negative 4 times negative 2 is positive 8. Then you combine like term and you are left with x squared minus 6x plus 8. And similarly, you do the same process and these are the numbers you're going to be left with. Okay? So let's compare. Okay, so when you compare all the answers, I want you to think about what is the rule to get the x term coefficient. Okay, right. Okay, so that's the blue coefficient. That's the middle term. Okay, and what is the rule to get the constant term, the red term? Okay, please pause the video and see if you can figure out what is the pattern that I see between the numbers here and the blue term for each one of them and the red term. Well, here's a quick summary. For the blue term, comparing this, it's actually the sum of the pink numbers, the two the constants, the two binomials.